In practice, there are several methods of message passing based IPC. The first and most simple form of message passing IPC that's also part of the POSIX standard is called pipes. Pipes are characterized by two endpoints, so only two processes can communicate. There's no notion of a message per se with pipes. Instead, there is just a stream of bytes that's pushed into the pipe from one process and then received into another. One popular use of pipes is to connect the output from one process to the input of another process. So the entire byte stream that's produced by P1 would be delivered as input to P2 instead of somebody typing it in, for instance. A more complex form of message passing IPC is message queues. As the name suggests, message queues understand the notion of messages that they transfer. So a sending process must submit a properly formatted message to the channel, and then the channel will deliver a properly formatted message to the receiving process. The OS-level functionality regarding message queues also includes things like understanding priorities of messages or scheduling the way messages are being delivered. The use of message queues is supported through different APIs. In Unix-based systems, these include the POSIX API and the System5 API. The message passing API that most of you are familiar with is the socket API. With the socket form of IPC, the notion of ports that's required in message passing IPC mechanisms, that is the socket abstraction that's supported by the operating system. With sockets, processes send messages or receive messages via an API that looks like this, send and receive. The socket API supports send and receive operations that allow processes to send message buffers in and out of the in-kernel communication buffer. The socket call itself creates a kernel-level socket buffer. In addition, it will associate any necessary kernel-level processing that needs to be performed along with the message movement. For instance, the socket may be a TCP/IP socket, which will mean that the entire TCP/IP protocol stack is associated with the data movement in the kernel. Sockets, as you probably know, don't have to be used for processes that are on a single machine. If the two processes are on different machines, then this channel is essentially between the process and the network device that will actually send the data. In addition, the operating system is sufficiently smart to figure out that if two processes are on the same machine, it doesn't really need to execute the full protocol stack to send the data out on the network and then just to receive it back and push it into the process. Instead, a lot of that will be bypassed. This remains completely hidden from the programmer, but you could likely detect it if you perform certain performance measurements.